Hi everyone, in this video we're going to be doing A-level Maths 9709 paper 45, October-November 2025 mechanics. This paper is 1 hour 15 minutes long, so we'll try to finish within the time limit, so let's get started. So for the first question, we are told that coplanar forces of magnitudes P Newton, Q Newton, 32 newtons and 21 newtons act at a point in the direction shown in the diagram. Forces are in equilibrium is the main keyword. Find the values of P and the value of Q. Okay, so to do this type of question, you should first split all the forces up into the horizontal and vertical components, and then you just equate them to each other. So let's start with the vertical components first. Okay, so you can start with the 32 Newton force. This one is going to be 32 sine 35 upwards. Similarly, we also have 21 Newton vertical component, which is 21 sine 47, also acting upwards. P newtons is just purely horizontal. And lastly, for Q Newton, we also have its vertical component acting downwards, which is Q. Okay, so let's so this angle probably be 35. So this is probably going to be Q cosine 35 degrees. Yeah, so that's all for the vertical forces. Now we're just gonna equate them together. Okay, so 32 sine 35 plus 21 sine 47 degrees equals to Q cosine 35 degrees. Okay, yeah, I think we can just find the value of Q directly in here. So Q is going to be just this value, 32 sine 35 over cosine 35 plus 21 sine, okay, 21, wait a minute. Oh, sorry. This angle is supposed to be 25 degrees. Okay, so this is going to be divided by cosine 25 degrees, not 35. Sorry about that. Okay, cosine 25 degrees. Okay, so yeah, just type all this into your calculator. And 32 sine 35 cosine 25 plus 21 sine 47 over cosine 25. You will get 37.2. I mean, since Newton's is already in the unit, so I mean Newton already included, so I think we can just leave this as our final answer for Q. Now we are ready to find what P is by taking the horizontal forces now. Okay, so for the direction of P, we have the 21 Newton force horizontal component, which is 21 cosine 47. And we also have 32 Newton cosine 35. And we also have Q sine 25 degrees. It's also 25. Yeah, that's all. So it's going to be P plus 21 cosine 47 equal to 32 cosine 45, 32 cosine 35 plus q sine 25. Okay. So now we just make P the subject. So P will be 32 cosine 35 plus Q sine 25. So Q, just to be safe, I'm going to put the exact value. Okay, so 32 sine 35 plus 21 sine 47 degrees over cosine 25 degrees times sine 25 degrees minus 21 cosine 47 degrees. So just type all of this into your calculator. You would get 27.6 to 3SF as your final answer. So yeah, this would be our final answers for this question. Let's move on to the next question. Okay, so for this question, we are told that an athlete runs along a straight horizontal road. The athlete starts from rest and accelerates at 0.5 meters per second square, reaching a speed of 7 v meters per second. Okay. The athlete maintains this speed of v meters per second for t seconds before decelerating at 0.2 meters per second square back to rest. So yeah, these are keywords. The athlete covers a total distance of 1,350 in 246 seconds. Okay. So for the first part, we're told to sketch the VT graph for this motion. Okay, so it starts from rest and then it accelerate at 0.5 meters. So the acceleration is constant until it reaches this v meters per second. Okay, so if the acceleration is constant, that means your gradient of your VT graph for that section will be constant. So it's just going to be a straight line with constant gradient and positive gradient. Yeah, so this is going to be V. And then after that, the athlete maintains the speed. So the speed is constant for t seconds. Okay, so you can just draw a straight line, horizontal line. So I don't know what this time is. They'd never say in here. Yeah, but then whatever time is in here, you just add t in here. And then after that, it decelerate at 0.2 meters per second square back to rest. Okay, so since here the deceleration is less, that means the gradient of the VT graph at that point is also going to be less. So we have to make it a bit less steep. Okay, so the most I can do is, okay, no, that's a bit too much. Okay, let me erase a little bit. Okay. Okay, can now like this. Okay, good. Yeah, so this is the 0.2 meters per second deceleration. Yeah, okay. Yeah, Yeah, so this would be our final answer. Let's move on to the next part. Okay, so for this second part, we are told to find t in terms of v, and we have to show that this equation is valid. Okay, so let's see what clues we can gather in here. Um, okay, so first clue is obviously the total distance and the total time taken. Okay, so one thing you must know is that the area under the graph for VT graph is equal to the total distance traveled. Yeah, so we can use that. So first we need to know all these dimensions like the height, the vertical height, as well as the length of the two parallel sides. So this one is going to be 246. Um, okay, and then okay. And then for this, obviously it's just going to be t, right? The length of that one. Yeah, I think that's all we have to really know for the area under this graph. Yeah, so let's put the formula. So the area for trapezium is half times the length of the parallel sides, which is t plus 246 times the vertical height, which is v. Okay, and then this would be equals to 1350. Okay, good. So yeah, just make your first equation. So multiply by 2, divide by v. So t plus 46, you would get 2 times 1350, which is 2700. Then you divide it by v, and then you get t is equals to 2700 over v minus 246. Okay, yeah, so this is our first answer where for t in terms of v. Now we have to form another equation in terms of t and v. So let's use the acceleration at 0.5 meters per second. So we can equate that to the gradient of this section here. Okay, so okay, what do we put? Okay, I think we can just put this as x, if I'm not wrong. Yeah, let's just put it as x. So y2 minus y1, so y2 is going to be v, y1 is 0, and then x2 is x. X1 is also 0. So it's just v over x. It's equals to 0.5 meters per second squared. So let's express this x in terms of v. So it's just going to be 2v. So this is your first equation. And then this one is obviously just going to be x plus t. Yeah, so now we can substitute 0.2 into the gradient of this section here. So again, we'll use the y2 minus y1. So y2 I'm going to take as a v. Then y1 is 0, and then over x2, which is x plus t. Yeah, x plus t. Yeah, x plus t. That's y2. Wait, no, x2, sorry. Minus 246. Okay. Yeah. Yep. So this one we can make it equals to minus 0.2 because the gradient is negative. Okay. Okay. I believe this is going to be a final equation. Minus 0.2 x minus 0.2 t minus 0.2 times minus 246, you get plus 49.2. Yeah, so just substitute everything. 0.2 times x 2v minus 0.2 2700 over v plus 49.2. Okay, I think we're gonna have to multiply by 492. Okay, let's just multiply by v first. So v squared minus 0.4 v squared minus 0.2 2700 minus 540 plus 49.2 v. Okay, right. So let's now move everything over. Wait a minute. What's going on? Oh, shoot. Okay. I realized I substituted it wrongly. Okay, let me just put it everything back. Okay, so this one will be minus 246. Yeah, so this one is gonna be so V is gonna be minus 0.2 times 2700, so minus 540 minus 0.2 times 246 times V. For 49.2 V plus 49.2 V. Okay. All right, now think we just need to move everything over. So move that over, you would get 1.4 v squared minus 49.2 times 2, 98.4 v plus 540 equals to 0. And then simplifying, you must get 7 squared minus 492v plus 2700. So yeah, this would be our final answer. You can write shown. And let's move on to the last part. Okay, so just now need to find the value of v while giving a justification for our answer. So we need to give a reason why we accept or reject an answer. Okay, so let's try factorizing it. I don't know if it will factorize or not, but let's try anyway. Okay, good. So it factorizes pretty perfectly. 7v minus 450 times v minus 6 equals to 0. Then you get 7v minus 450 equal to 0. then V is gonna be 450 over V. Okay, 450 over V, or V minus 6, you get V equals to 6. So as you can see, we have two answers. We need to reject one of them. Okay, so as you can see, there's no negative answer. So 450 over 7, that is 646. That's 64 meters per second square. I mean, okay. Yeah, I think we have to reject this because there's no way that an athlete can reach 64.2 meters per second. So you have to use a bit of common sense here. So yeah, this would be our answer for this part question. Let's move on to the next question. Okay, so for this question, we are told that a car of mass 800 kg is moving on a straight road when the car is moving at a constant speed of 20 meters per second. On a horizontal section of road, the engine of the car is working at P watts. Okay, when the car is moving at a constant speed of 12 meters per second up a section of the road inclined at sine inverse 0.15 to the horizontal. So this is like going up a hill. The engine of a car is also working at P watts. Okay. Okay, so on both sections of the road, there is a constant force of magnitude R newtons resisting the motion of the car. So this is the resistive force of R newtons on both sections. Okay. So for part A, we need to find the value of R and the value of P. Okay, so let's draw a diagram first. So this for the horizontal road. Okay. So for the horizontal road, there's going to be a driving force, Fd. And then there's also the resistive force, R Newton. And since it's moving at a constant speed, Fd must be equal to R, okay? So using that, we can easily find what P is, okay? Using P equals to Fd V. So FdV is just RV, and RV is, oh wait, okay. Oh, well, I guess we don't know. So that's just going to be 20R for now. So this is going to be our first equation. Okay. Now, we're told that the car is moving constant speed of 12. So this is the second scenario. It goes up a section of road inclined at sine inverse 0.15. Okay. All right. So for the inclined section, there's also the driving force Fd. Actually, let me use a different letter. I don't want to confuse this. Yeah, let's call it Nd as a driving force. There's also the constant resistance of R. And this time you also need to take into account the weight of the car, which is 800 G. Okay. So the horizontal component of the weight will be resisting the motion of the car for this case. So this uh, horizontal component is going to be 8,000 uh, sine 0 point inverse sine 0 point sine inverse 0.15. Yeah. So for this P is going to be NdV, and ND is just equals to R plus 8,000 sine inverse 0.15. So just 8,000 times 0.15. And then V is 12. Yeah. Okay. So simplifying, you get 12R plus 8,000 times 0.15 times 12. Yeah, you'll get 14,400. Yeah, so this is number 2. Yeah, so let's equate equation 1 and equation 2. So this is going to be 20R equals to 12R plus 14,400. So this is going to be 8R equals to 14,400. Then R would just be 1800, sorry, 1800. PW, wait, no, 1800 newtons. Yeah. So this is for R. Now we can just straight away find P by substituting back into equation 1. 20 times 1800. So since P is in watts, you don't have to convert to kilowatts. Yeah, so P is 36,000 watts. So yeah, these two would be our final answers for the first part. Let's move on to the next part. Okay, so for this second part, we are told to find the acceleration of the car when it is moving at 10 meters per second up the inclined section of the road. So it's going up with the engine working at 32 kilowatts. Okay, so I believe first we need to find the driving force using the P equals to F dV formula. So FD is just going to be P over V. So that's going to be 32 times 10 to the power of 3 divided by 10. So 32 times 10 cubed divided by 10, you get 3,200 newtons. So this is our driving force. Now, yeah, we'll draw the diagram again. So driving force is 32,000 newtons. And then we also have the resistive force R, which we know is 1800 newtons. And we also have the weight, which is 800 G. And as we know, since it's going up, the horizontal component of the weight parallel to the plane is going to be 8,000. Since G is 10, 8,000 sine inverse 0.15. Yeah, so this is going to be, so now we can use F equals to MA. So F is going to be 3,200 minus 1,800 plus 8,000 times 0.15. And then M is 800 times A. Yeah. It's going to be 200 equals to 800A. Then A is going to be 200 divided by 800, which is 0.25 meters per second squared. So yeah, this would be our final answer for this part as well as the entire question. Let's move on to the next question. Okay, so for this question, we're told that a particle P moves in a straight line at time t seconds after leaving a point O on the line. Acceleration a meters per second square of P is given by a equals to kt minus 3, where k is a positive constant. Okay, at time t equals to 0, the velocity of P is 1 meters per second. Okay, so for first part, we're told that given P is never at instantaneous rest, so that means there's no time where V is equals to 0. We have to show that K is more than 4.5. Okay, all right. So, okay, so first we need to find the expression for V in terms of t, which we can do easily since we know A is just dv dt. So we just have to integrate the expression for A with respect to t. So V is just going to be integral of kt minus 3 dt. So this is going to be kt squared over 2 minus 3t plus c. Um, okay. I believe there is. All right. Let's just find the kt first. Okay. So let's just sub t equals to 0 and v equals to 1. Okay. So k 0 squared over 2 minus 3 times 0 plus c equals to 1. Okay, so all this will be just 0, then you get c is equals to 1. So we got our constant. Yeah, so v is just going to be kt squared over 2 minus 3t plus 1. Okay, so now I believe we have to set v more than 0. Then we'll have kt squared over 2 minus 3t plus 1 more than 0. Yeah, then this would be kt squared minus 6t plus 2 more than 0. Okay. Okay, I don't think we should make it more than 0. Let's just make it equals to 0, sorry. Then we can find what values k cannot take. Okay, so it's never equals to 0. So okay, so here we need to use our discriminant. Okay, so since this cannot be equal to 0, b squared minus 4ac must be less than 0. Okay, yeah, so b squared minus 4ac has to be less than 0. So b squared is minus 6 squared, then a is k, and c is 2. Simplifying, you get 36 minus 8k less than 0. Then you get 8k more than 36. Then divide by 8 on both sides, you get 36 divided by 8, which is 4.5. So yeah, this would be a final answer for the first part. Let's move on to the next part. Okay, so for the second part, we are told that instead k is equals to 2.5, we need to find the total distance traveled by p in the interval for t between 1 and 3 seconds inclusive. So keyword here is total distance, not displacement. but I don't think it should be a problem for us since P is not in instantaneous rest at all. So we can probably just take the displacement straight away. Okay, so yeah. Um, okay, so V, let's just copy down what V is. So V is equals to KT squared over 2 minus 3D plus 1. Oh, sure, I forgot to substitute 2.5. So 2.5 divided by 2, you get 5 over 4 d squared minus 3d plus 1. Okay, now we can just find our expression for displacement. Okay, so yeah, this is going to be 5 over 4 d squared minus 3d plus 1 dt. So 5 over 4, keep alone, and then t squared just integrate, you get t cubed over 3, and then minus 3, you integrate t, you get t squared over 2, and then for 1, you just get t plus c. So this one will just be 5 over 12 t cubed minus 3 over 2 t squared plus t plus c. Okay, all right, so at time t equals to 0 velocity, I mean the displacement must be 0 at t equals to 0. So equals to 0 and s equals to 0. If you do your calculation, you will just get c equals to 0. Therefore, s is just everything without the c. Okay. And now we can just substitute t equals to 1 and t equals to 3. So this would be 5 over 12 minus 3 over 2 plus 1. 5 over 12 minus 3 over 2 plus 1. That's strange. Okay, I believe, yeah, you'll get minus 1 over 12 meters. Don't panic. This just means that the direction of displacement is not in the direction of movement. So it's moving in the negative direction, but yeah. So, okay, now let's substitute t equals to 3. Okay, you know what? Let's first just substitute v equals to 0. Then we can know our inflection points. Okay? Yeah. So let's substitute 5 over 4 t squared minus 3t plus 1 equals to 0. And then you multiply by 4 on both sides, you get 5t squared minus 12t plus 4 equals to 0. Then you would get t minus 2, then 5t minus 2. Yeah, so you would get t equals to 2 and t equals to 2 over 5. Yeah, so I think we can reject this because we're not interested in this time. We're only interested in the times between 1 to 3. So yeah, this is instantaneous rest. So I think I should write here sub v equals 0. Okay, let's sub t equals to 2 into s. So s would just be okay, s equals to 2. It's gonna be 5 over 12 times 2 cubed minus 3 over 2 squared plus 2. It's going to be 5 over 12 times 2 cubed minus 3 over 2 squared plus 2. You'll get minus 2/3 meters. Yeah, so that's the distance. Okay, now we're going to substitute t equals to 3. It's probably going to be a lot lesser, but that's okay. So s 5 over 12 3 cubed minus 3 over 2, 3 square plus 3. You get 5 over 12, 3 cubed minus 3 over 2, 3 square plus 3. You get 3 over 4 meters. Okay. All right. That's the distance traveled between. Okay, so this is the point O. So at t equals to 2, it's at negative, and then t equals to 3, it's here, and t equals to 1. Let's find out what t equals to 1 is. Okay, 5 over 12 minus 3 over 2 plus 2, you would get probably a negative answer. Wait, sorry. Oh, wait, we didn't get a negative answer. Okay. Yeah, okay. All right, so it's just 11 over 12 meters. Okay. So 11 over 12, that is more than 3 over 4. So t equals to 1 is here. Okay, so it travel like this. Yeah. So it travel from t equals to 1 to t equals 2, and then from t equals to back to t equals to 3. So yeah, to find the total distance, just take the magnitude of the displacements for T1 and T2 plus T3. So T1 is 11 over 12 plus T2, which is 2/3, plus T2 again, which is 2/3, plus T3, which is 3 over 4. Yeah. So you would get 3 meters as your final answer. So yeah, this would be our final answer for this question. Let's move on to the next part. Okay, so for this question, we're shown a diagram with a particle P, mass 6 kg on a rough plane, inclined at an angle of 30 degrees to the horizontal. So this is the particle that they're talking about. So the weight is going to be 6g. And 2 light inextensible strings are attached to P. The strings pass over small smooth pulleys which are fixed at the end of the planes. Okay, the non-vertical parts of the string are parallel to a line of greatest slope of the plane. Okay, particles Q and R of masses 5 kg and 2 kg respectively hang vertically at the ends of the string. Both strings are taut, so that means there's tension in them and the system is released from rest. Okay, this is the last one. It is given that the tension in the string attached to Q is twice the tension in the string attached to R. Okay, so for the first part, we need to find in terms of G, so we cannot substitute G equals to 10, the tension in each of the strings and the magnitude of the acceleration of the particles. Okay, so first off, let's label all the forces acting in this system. So we have this 2 kg, which is 2g, and 5 kg, which is 5g. Okay, here 5g. And then the tension in the string, there's tension in the string attached to Q is twice the tension in the string attached to R. So this one is just going to be T, and this one is just going to be 2T. Okay, all right. So that's for the individual particles for Q and R. Let's do it the same for P. So P, this part is going to be 2T. This part is going to just be T. And the system, when it's released, it's definitely going to move in this direction since 5 kg is heavier. So it's a rough plane, so there's going to be friction acting. So I'll just label the friction in here, but that's only for P. So FP, and we also have the normal reaction force, which I'm going to label as NP. Yeah, these are all the forces in here. Okay. Okay, let's do for all of them. Okay. I mean, let's take it for each system. So first we'll do only for QP, right? So for QP, the tension is only going to be okay. So let's just do for Q. So Q is going to be 2T minus 5G. That's going to be 5A. I'm using Newton's second law here. So it's supposed to be 5G minus 2T equals to 5A. And then I'll just make A the subject. You'll get 5G minus 2T over 5. This would be G minus 2 over 5T. So this is the first equation. Q, okay. I believe R now. Yeah, let's do R. So for R, it's T minus 2G equals to 2A. Yeah, so this 2G times 2A, and then G is G minus 2 over 5T. And then T minus 4 over 5t. So move the 4 over 5t to the other side, you would get 9 over 5t. Yeah, and then this is going to be equal to 4g. Then t is just going to be 5 over 9 times 4g, which is going to be 20 over 9g. Okay. And yeah, so this is the tension in the string. Now we can automatically find the acceleration, which is g minus 2 over 5t, which is 20 over 9g. That's going to be 1 minus 2 over 5 times 20 over 9. 1 over 9g. So I believe these would be our final answers for the first part. Let's move on to the next part. Okay, so before I start with this part, I just realized I made a mistake in this question. So I just put the value of t, but they asked for the tension, sorry, in tension in each of the strings. So in TQ, so TQ, that's the one that's twice. So TQ is just going to be 2 times 20 over 9, which is 40 over 9g. And then TR, that's the other one. So TR is 20 over 9g. So yeah, these two are our final answers. Okay. Okay, and there's also another error that I made in part B of question 4B. So I substituted this one wrongly. Should be 1 in here. So this is negative 1 over 12. So this here is also negative 1 over 12. So this would give you 2 meters as your final answer. So with these two errors rectified, we can move on to this part 5B. Okay, so for 5B, we need to find the coefficient of friction between P and the plane. Okay, so yeah, for that, we need to just focus on P alone, right? So we just focus on the horizontal forces, okay? I think let's just draw a diagram of P in here. So this is NP, and then this is the weight, 6G if I'm not wrong. Yeah, 6G. And then we also have the tension in here. This is 2T, and then here we have FB, the friction of P. Yeah, it's just these. Okay. All right, so yeah, now we can find out. All right, so let's find out what NP is first. So NP is just the vertical component of the weight, and the angle here is 30 degrees. Okay. So this is just going to be 6G cosine 30 degrees. So 6 times 10 times cosine 30. Yeah, so this is 3 square root 3G. Yeah, that's NP. And now for FP, just going to be NP mu. So it's going to be 3 square root 3G times mu. So this is FP. Now let's do F equals to MA, Newton's second law. So since it's moving in this direction, we'll take the forces acting in this direction first. So that includes the horizontal component of your weight, which is 6g sine 30 degrees, plus 2t, which is t q 40 over 9g, 40 over 9g, and minus t minus fp. So t is 20 over 9g minus t, which is tension. Wait, t is no, fp, sorry, 3 square root 3 mu. This is equals to ma, so mass is 6 kg, and then a is 1 over 9g. Okay, now we're just gonna move this over. So 3 square root 3 mu g is gonna be 6g sine 30, 6 times sine 30. It's gonna be 3g plus 20 over 9g minus 6 over 9g, just 2/3, 2 over 3g. Okay. Yeah, so we can cancel out the g. Okay, so 3 square root 3 mu equals to 3 plus 20 over 9 minus 2/3, which is 41 over 9. Then mu is going to be 41 over 9 times 1 over 3 square root 3. So that's going to be 0.8772 SF. So yeah, this will be our final answer for the second part. Let's move on to the last part. Okay, so for this final part, we're told that when the system is released from rest, P is at the midpoint of the plane. In the subsequent motion, R does not reach the pulley at the top of the plane, and P takes 1.5 seconds to reach the pulley at the bottom of the plane. Okay, so using this, we need to find the total length of the plane. All right, so yeah, so basically we need to find this length, and then to get the final answer, just multiply by 2. So this length is actually equals to the length traveled by P from here all the way to here. So to find that distance, we can use the Suvat equation. All right, so since acceleration is constant, and we have time, the initial speed, which is 0, we can use S equals to ut plus half at squared. It is also in your MF19 if you can't remember it. So u is 0, so it's just going to be half, and a would be a is 1 over 9, okay, 1 over 9g, and then t is 1.5 seconds squared. So half times 1.5 seconds squared times 1 over 9, you get 1 over 8g. So this is in meters. So total length would just be times 2. It would just be 1 over 8 times 10 times 2, which is 5 over 2 meters for the total length of the plane. So with that, we can move on to the next question. Okay, so for this question, we are told that two particles A and B of masses Km and m respectively, where K and m are constants, are free to move in a straight line on a smooth horizontal plane. Particle A is projected towards B with speed 2u, and at the same instant, B is projected towards A with speed u. So let's draw that out. So A is B. So B is projected towards B with speed 2u. The same instant, B is projected towards A with speed u. Let's write down the masses here. And we're told that the particles collide after the collision. Speed of A is u. Both particles move in the same direction as A's original motion. So that means A and B, they both move to the right. And speed of A is u, and then V is unknown. So I'll just write it as V for now. Yeah. Okay, and then after that, we're told that it's given that 35% of the total kinetic energy is lost in the collision. Find in terms of u the speed of B after the collision. So we need to find V in terms of u. Okay, so first of all, let's use our conservation of momentum. Okay, so since momentum is a vector quantity, this right-hand side, like if it's moving to the right, the velocity is going to be positive. To the left is going to be negative. So therefore, 2kmu, that's positive, minus mu, that's before, equals to kmu plus mv. All right, now let's cancel out the m's. So you get 2ku minus u equals to ku plus v. Okay, and then v is just going to be ku minus u. Yeah, so this would be, okay, let's factorize out. So yeah, this is going to be k times u minus 1. So this would be our first answer. I mean, our first equation. Yeah, now we're going to make an equation using the KE. So to do that, we need to find the total KE before and after the collision. So let's find for before first. So KE is just half times m, which is Km, and then V square, which is the 2u square plus half mu square for me. So this is just going to be k over 2m times 4u squared plus half mu squared. So this is going to be 2kmu squared plus half mu squared. So this is equation 2. And now after, same thing, half km u squared for A plus half mv squared is equals to k over 2mu squared plus half mv squared. So this is equation 3. Yeah. Okay, so now 0.35 loss, that means 65% of the original kinetic energy is retained in the kinetic energy after. So this is going to be 65%, which is 13 over 20 times 2kmu squared plus half mu squared equals to k mu squared plus half mv squared. Okay, so simplifying, so just expand 15 over 10. 13 over 40 mu squared. Okay, mu squared plus half mv squared. Okay, so now just make mv squared the subject. Get 13 over 10 minus half, which is 13 over 10 minus half, which is 4 over 5k mu squared plus 13 over 40 mu squared. Okay, now we can cancel the m out. Multiply by 2 on both sides. You would get 8 over 5k u squared plus 13 over 40 times 2, which is 13 over 20 u squared. Okay, so this is our first equation, fourth equation. Now we're gonna sum our first equation into the fourth equation. So v squared, according to the first equation, is k squared times u minus 1 squared. So u minus 1 squared is u squared minus 2u plus 1. So this is k squared u squared minus 2ku plus k squared. Give me a while. Oh, shoot. Okay. All right. It's gonna be a bit laggy in here. So k square u square minus 2ku plus k square equals to 8 over 5k u square. Wait, let's see. U square plus 13 over 20 u square. Okay. Okay, sorry everyone. I made a small error in factorizing this. So this is supposed to be u times k minus 1. Yeah. All right, so here we know u square, yeah, u square minus k minus 1, u square, k square minus 2k plus 1. So u square, k square, 2ku square plus u square, ku square, u square equal to this. All right, so we can cancel out the u squares. Okay, so you get k square minus 2k plus k square. Wait, is it k square? Wait. Oh wait, this just 1, sorry. It's just 1. Yeah, equals to 8 over 5k plus 13 over 20. Okay, so this is k square minus 2k minus 8 over 5k. That's going to be minus 18 over 5k. 1 minus 13 over 20, which is plus 7 over 20. So it's equals to 0. So multiply by 20 on both sides. Get 20k squared minus 18 over 5 times 20 minus 72k plus 7 equals to 0. Okay, so now we can factorize this. So you get 2k minus 7 times 10k minus 1 equals to 0. Yeah, then you get 2. Oh my gosh. Okay, give me a while. All right, then you get 2k minus 7 equals to 0. Then k 7 over 2. Then here k is equals to 1 over 10. For v, it's gonna be k. So, so we know that v has to be more than 0, so k has to be more than 1. So we're gonna reject this, right? So then we get v is equals to u times k minus 1, which is 7 over 2, minus 1, which would be 5 over 2u. So yeah, this would be a final answer for this entire question. And we have also come to the end of this paper. So I hope you found this video helpful. If you did, please make sure to like and subscribe to this channel for more future videos regarding A-level maths and further maths past papers. If you have any questions, queries, or doubts, please feel free to leave them down in the comments below. And I'll see you again next time. And please don't forget to click in the first link in the description if you're interested in my tutoring services under Smile Tutoring. If you're doing Mechanics Paper 4 and Probability and Statistics Paper 5. So yeah, with that, I'll see you guys next time. Okay, thank you.